Hi everyone. So today's lesson from Unit 7 is about arc length and the area of a sector. First of all, a sector is defined as part of a circle or a region that's bounded by two radii and an arc of the circle. So AP and BP are two radii of our circle, and the third side, if you will, is this arc from A to B, which I'll label just with a little lowercase a. Before we find the length of that arc from A to B, or the area of that shaded sector, we have to first review a couple of formulas. And those formulas are for circumference and area of a circle. If you recall, circumference of a circle can be found by doing 2 times pi times the radius. Or you can call it pi times the diameter, because the diameter is equal to 2 times the radius. Okay, for our purposes today, we're going to be using the formula for circumference. Area of a circle is given by the formula pi times r squared. Alright, when we want to find arc length, now first note that arc length is different than the measure of the arc. The measure of an arc is in degrees, and the length of the arc is in something like centimeters, meters, feet, inches, and so on. So to find arc length, since it is part of the circumference of a circle, arc length is a fraction of the circumference of the circle. So in order to calculate arc length, what we need to do is take and divide the angle measure, that's the central angle measure, by 360, and multiply by circumference times 2 pi r. And remember that this central angle would be equal to the measure of the arc and vice versa. So we want to take the arc, or the angle measure, divided by 360 times 2 pi r. Okay, to find the area of a sector, since a sector is a part of the area of a whole circle, the area of a sector is a fraction of the area of the whole circle. So, area of a sector is equal to, again, your angle divided by 360 times pi times the radius squared. I'll just shorten that to be a divided by 360 times pi r squared. Now think about it, like when you're finding, say, the length of a semicircle, and we're going from one end point of the diameter to the other, right, it should make sense to you that this is 1/2 of the whole circle. And the fact that it's 1/2 comes from the fact that it would be 180 divided by 360, and then we would multiply by 2 pi r. So it would be half of the whole way around the circle. Likewise, an area of a sector, again, let's use that semicircle as an example. If I color in half of the circle, then it should make sense that the area of that sector is 1/2 of the entire circle. And it would come from taking 180 divided by 360 and then multiplying it by pi r squared. And again, the 180 over 360 reduces to 1/2. Okay, let's practice some. Okay, so I've created a few questions that work out pretty nicely. And by that I mean that the fractions that you get aren't too crazy. For instance, in part A, well, first of all, the directions say, find the length of arc AB. Leave answers in exact form, and then round to the nearest tenth. Exact form means that there's going to be pi in your answer. Round to the nearest tenth means that you want to round to 1 decimal place. Alright, so if we take a look at this first one, we've got a central angle of 90 degrees, so our arc must be 90 degrees as well. And if you think about it, if I were to trace this out, think about what fraction of the whole way around the circle you're looking at. And we're looking at 1/4, and that's because 90 over 360 is going to reduce to 1/4. And we don't want to say that the length of this arc is 90 degrees, that's the measure. to find the length, we're going to use that radius to help us find the circumference. So notice that the radius is measured in inches, so the length of the arc needs to be in inches as well. So we're going to take the 90 divided by 360, and I'll just give you a little refresher. Arc length, again, the formula is A divided by 360 times 2 pi r. So that's why I have 90 over 360, and then I would do 2 times pi times 10, because this is my radius of 10. 90 over 360 reduced to 1/4. 2 times pi times 10 is going to give us 20 pi, and let's put it over 1. As a fraction, this would become 20 pi over 4, and then you want to reduce that, and we end up with 5 pi inches. Okay, this is the exact answer, and I'm always going to ask for that first. And then we want to get the approximation. And this is where you can either do 5 times 3.14 or use the pi key on your calculator. In the end, it would round to 15.7 inches. Think of that final answer in decimal form as being practical. Like 15.7 inches may mean a lot more to you than 5 pi would. All right, let's check out the second example. So this time our central angle is 60 degrees. The measure of the arc would be 60 degrees, and we have to find the length of the arc. So we're going to use this radius of 12 centimeters. So we want to take that angle, divide by 360, and multiply by 2 pi r. So 60 divided by 360 times 2 times pi times 12. Reduce your fraction, and again this reduces nicely because it's the notes. Okay, so 60 divided by 360 reduces to 1 over 6. 2 times pi times 12 would simplify to 24 pi, and put it over 1. Multiply across the numerator to get 24 pi, and across the denominator to get 6. Reduce it to 4 pi centimeters. Again, that's the arc length in its exact form. And then use either the pi key on your calculator or 4 times 3.14 to get the approximate answer. And when you do, you should come out with 12.6 centimeters. Okay, area of a sector is next. Okay, to find the area of a sector, again, we're going to take that angle measure, divide by 360, and this time we're going to multiply by pi r squared because we're finding the area of the sector. So we want to use the formula for area of a circle. Remember that our central angle will give us the measure of our arc, and so we want to take in part A and do 90 divided by 360 times the formula for area of a circle, so pi times our radius of 10 inches squared. 90 over 360 reduces to 1/4. Can you see that it's 1/4 of the way shaded? Pi times 10 squared will simplify to 100 pi, because 10 squared is 100. Put it over 1. Multiply your fractions to get 100 pi over 4, which is 25 pi. And this is going to be in inches. Okay, the approximation then, once you multiply 25 times pi, is going to be around 78.5. And I forgot to mention this should be in square inches. So this is exact in terms of pi. This is the approximation. Okay, last one. We are going to take and use this angle measure of 60 degrees to do 60 divided by 360. That tells us what fraction of the circle we're working with. And then we want to multiply by pi times our radius of 12 squared. 60 over 360 reduces to 1/6. 12 squared is 144 times pi. Simplify it, and it becomes 144 pi over 6. Divide that out to get 24 pi square centimeters. Okay, so that's the exact answer. Approximation, take 25 times pi and we get 75.4 square centimeters. Alright, that's it for arc length and area of a sector. Let me know what questions you have.